When we consider a fluid, a molecule inside the bulk of the fluid is surrounded by molecules from all the sides and thus is pulled equally in all the directions. However, a molecule at the surface of the fluid has an asymmetric distribution of the molecules and has a net force in the downward direction. Because of this, a molecule on the surface has a tendency to go inside the bulk of the fluid instead of staying on the surface. But when this happens, the molecules inside the fluid become more densely packed. So some molecule is pushed back to the surface, and there is a continuous turbulence on the surface of fluid. But on an average, there is a higher tendency of the molecules on the surface to go inside the bulk of the fluid. Therefore, the surface of fluid is a little stretched, which can be considered similar to a stretched membrane or a rubber sheet. So any such section of the surface of fluid is pulling the other. This force per unit length on the surface is called the surface tension and has the units of Newton per meter. Because the surface of a fluid is stretched, so it tries to reduce the surface area of the fluid. Let us take an example of a frame like this, where one side of the frame can slide freely. If we dip this frame in a soap solution, then we will see that this wire slides such that the area of surface is reduced. This happens because the molecules on the surface of the fluid tend to go inside the bulk, which puts the surface in a stretched state, causing it to reduce the surface area and thus causing the wire to slide. We can also say that as a molecule on the surface has a net force towards the bulk of the fluid, so when a molecule on the surface moves in the direction of the net force, positive work is done by the system, and thus the potential energy of the system is reduced. This means that the molecules on the surface have higher potential energy as compared to the molecules inside the bulk. This extra energy possessed by the surface of a fluid is called the surface energy and is measured as the energy per unit area of the surface. In this experiment, if we consider the surface tension to be equal to S and the length of this wire to be equal to L, then the force on the wire will be equal to S into L from each of the two surfaces. Therefore, total force on the wire will be equal to 2S into L. If we apply an equal external force on the wire such that the wire is made to move slowly by a distance x, then the external work done on the system will be equal to this term. And this work is stored as the potential energy of the system in the form of the increased surface energy. As the molecules from the bulk are pulled to the surface in this process. As the surface area increases by L into x from both the sides, that is 2L into x overall, So the change in surface energy per unit change in area comes out to be equal to the surface tension. This means that surface energy is just another representation of surface tension, because even the units of surface energy are effectively the same as that of surface tension.